Well, hello, 5th grade mathematicians. Today, we're going to do entry task day 108. Number 1, enter the quotient 854 divided by 12. So, we have a division problem, and our dividend is 854. Our divisor is 12, and we're looking for the quotient. So what I want to know is how many 12s go into 854. So I'm going to start with 12 into 800. Okay, well, 12 doesn't go into 800 without regrouping, but it does go into 85 tens. And so 12 goes into 85 if I counted by 12s. 12, 24, or if you know your times tables, you could do your times tables with that. So 84 is as close as it gets without going over. So I have 7 of those, right? And I'm having some. And 7 times 12 is 84. And we'll subtract. And we bring down. And now we want to see how many 12s go into 14. And we know we already wrote our multiples of 12 over there, and we see that 12 goes into there one time, and 1 times 12 is 12. And when we subtract, we have a remainder of 2. We're going to write our remainder as a fraction. So the quotient of 84 divided by 12 is 71, and 2 12s. In 4th grade, you would have written that as 74 remainder 2. All right, let's take a look here at problem number 2. Which expression is equal to 5,342 and 72 hundredths? Well, as I look at this particular problem, I see that I have 5 in the thousands place. And the only one of these that has 5 thousands is right here, B, 5 times 1,000. So let's just check to make sure that the other place values are right. We have 3 hundreds. We have 4 tens. We have 2 ones. Ooh. We have 7 tenths. And we have 2 hundredths. So yes, that does confirm. I'm just going to highlight this whole thing. B is the correct expression. Problem number 3. Enter a positive value for B that makes this statement true. 12 times B is greater than 12, but less than 24. So I know that 12 times 1 is equal to 12. And I know that 12 times 2 is equal to 24. But we're looking for a product that is greater than 12, but less than 24. So our product is going to fall between 12 and 24, which means that my multiplier has to be between 1 and 2. Right? So I know that 12 times anything greater than 1 but less than 2. And I'm just going to put 1.1. Although you could put anything up to 2. Whoops, that doesn't look like a 1. Okay. Problem number 4. Enter the number that makes the equation true. Well, as we look at that, we see that we are adding mixed numbers. And we know that when we add mixed numbers, we have to have an equivalent fraction. So what I need to do is I need to make 2 3/8 equivalent to 2 and how many 24ths? And the question that I always will ask myself is, how do I get, so I take what they give me. They give me the denominators here, okay? And how do I get from 8 to 24? Well, I could add, because 24 is greater than 8, but I know that if I'm using the concept of making equivalent fractions, I'll actually be multiplying. And I know that 3 times 8 is 24. I know that because we're looking for an equivalent expression, that I can't change what the fact that these fractions are equal. In other words, they look different. 3/8 looks different than 9/24, but we know that they are equal values. And I always like to think, when I talk about equal values, I'm like, well, how many different ways can you show $1? For example, $1 is also equal to 4 quarters. They look different, but they equal the same thing. And that's the idea there with equivalent fractions. So the number that makes the equation true is 9. Next question. Enter the number of kilograms equal to 4,600 grams. Again, we've been doing, consistently been doing conversion problems. And we'll start with what they give us, 4,600 grams. And they want to know how many kilograms that is. So let's write down our conversion. I know that 1,000 grams is equal to 1 kilogram. Again, I'm going from a smaller unit to a larger unit, and when I do that, I'm going to be dividing. So I'm going to take 4,600, I'm going to write it differently, divided by 1,000. Remember, when we have fractional values, it's the same as division. And I'm going to look for common factors. Well, I know that 10 goes into both of those, and there's still another 10, right? And I know when I divide anything by 10 here, all the digits will shift to the, if I'm dividing, they shift to the right. So this would 46 divided by 10 is equal to 4 6/10. Right? And the other way of remembering that is, and I'll just write it this way again, because it's good to be able to look at things differently. And so again, here's my decimal point. All right? And if I'm dividing by, remember how we write 1,000 in exponential form. It's 10 to the third power. And that gives us a little clue for every power of 10, we shift the digits one place. And when we're dividing, all the digits shift to the right. When we're multiplying, all the digits shift to the left. So if my digits shift to the right when I'm dividing 3 places, I will end up with 4 6/10. So I encourage you that as you're doing these problems to think of the different strategies that you've learned, and sometimes just go ahead and check, make sure you can come up with the same answer in the different ways that you strategize. All right, reach out to your teacher if you have any questions.